Hey everyone, my name is Chris Houlihan. I'm a mechanical design engineer and a field representative here at Converge. At Converge, we have many years of experience providing the best design and development services in the US. Today we're going to dive into new content for 2017 SOLIDWORKS Plastics, including some cool new options for leveraging previous design data that will save you loads of time. SOLIDWORKS Plastics 2017 provides more flexibility and control when defining your plastic design studies, as well as better performance and accuracy for interpreting those results. Let's take a look at some of the many new features found in SOLIDWORKS Plastics 2017. The first thing you will notice is a more unified interface, mimicking the rest of SOLIDWORKS, including new icons introduced in SOLIDWORKS 2016 and refined in this release. There is now a new setting focused on load time performance for files that contain SOLIDWORKS Plastics information. This option now allows you to defer loading SOLIDWORKS Plastic data until you activate the SOLIDWORKS Plastics tab from the Feature Manager. Once activated, SOLIDWORKS loads the needed information on demand. There are now new enhancements when working with configurations in SOLIDWORKS Plastics. You now have the ability to work with derived configurations, which give you more ways to work with different design criteria. Now let's look at some of the new options available when designing a SOLIDWORKS Plastics design study. The first thing you will notice is a new option that allows you to leverage your previous design data. You will no longer need to start from scratch when redefining the study. This saves information such as cavity, runner, cooling, and domain definitions previously defined. However, in this circumstance, we want to look at some new options in those previous steps, specifically for defining a runner system. To do this, we will activate the runner and cooling system design option. Once loaded, we will activate the runner system design and remove all the previous information that was saved from before. In this case, I would like to show the new draft angle option available when defining the runner system. This new option gives you more ways in which to define elements of your runner system when start and end values don't meet your specific needs. In this example, we've selected 3 lengths where the runner system interfaces with the cavity and the draft is applied to those segments. This new option can be used in combination with the previous definition method where you can specify and start and end value. For this example, we'll add a few more lengths of runner, varying size to get exactly what we're looking for. We will end with, again, using draft for where the runner interfaces with the sprue. Once that's finished, let's take a look at some of the powerful new options available for surface mesh creation, which include refinement options. SOLIDWORKS provides the ability to control mesh through nominal size, but now you have new ways in which to refine this definition. With automatic SOLIDWORKS, we'll refine the mesh around areas of high detail in your design. Assigning size allows you to specifically define the mesh size in specific areas of your design. Or using the automatic and assign, you can use a combination of the two, which offers the greatest flexibility. In this example, we will refine the mesh around this boss in the corner of the cover, as this might be an area we really want to understand in more detail. You may also notice that the SOLIDWORKS has conveniently turned on selection filters for us, making this process even easier to select the faces. Once finished, we will let SOLIDWORKS create the mesh using the parameters that we've applied. Once the mesh has been created, you can see the nominal 3mm mesh size throughout most of the design, with a refined mesh automatically applied around the high detail areas, and finally, the mesh we specifically applied to the boss in the corner. Now that the surface mesh has been applied, we will quickly move through the rest of the setup process so that we can create the solid mesh from the surface. This will take a few moments to solve, but we want to make sure we show some of the powerful new options available when adding injection locations to the design. Once the solid mesh has been created, we'll again navigate through the rest of the setup procedure and then let SOLIDWORKS save the SOLIDWORKS plastic setup files locally. This is something that, though takes a moment, but will allow you to return to your simulation setup at any time. Once the mesh has been completed, we're ready to define some of the injection characteristics for the runner system we created previously. To start, I'll add a simple injection point at the top of the runner system like I normally would, and we will use an injection diameter of 10mm. However, there are now new options for defining the injection process, specifically a new control valve option. These will be the locations where our runner system interfaces with our cavity. You can choose to manually select those locations, but SOLIDWORKS Plastics has conveniently new feature to automatically select them for you. In this case, you can see that SOLIDWORKS has found the 3 locations previously mentioned with no effort on our part. Even better, within each control valve, you have more refined control to specify when the valve opens and closes. From the pull down, you can choose from volume ratio, which activates the valve based on what percentage of the cavity has been filled for both open and close steps. You can also choose to manually specify the time at which the valve opens and closes. And lastly, the powerful option to automatically determine the optimal open and close times for the valve. Regardless of which option you select, the open and close times will be available in the flow report generated once the study has been run. In this example, we will specify that the center valve should wait until 30% of the cavity's volume has been filled through 100%. Or the rest of the cycle. At this point, you would now run your fill and pack analysis based on the settings you've provided. However, for time's sake, I'll switch to a configuration where I've already run the simulation based on the parameters we've just defined. Now that the configuration results have loaded, let's take a look at some of the new options available for interrogating our results. One of the first things you will notice is the inclusion of the minimum and maximum results next to the results display, giving you a better insight into these values. As you change these values, those min and max value will remain visible for reference. There is now also more refined control over the speed at which result animations are shown, as you can slow down or speed up the results to get better understanding. Here is where we can also see the delayed opening of the control valve that we had specified previously. Notice that it doesn't start opening supplying material to the cavity until it is already 30% filled. There are also some slight changes to the display of weld lines. Specifically, now the colors are more representative of their condition. Red is where the melt fronts meet at small acute angles, while blue is where the melt fronts meet at large obtuse angles, making it easier to interpret how the weld lines are being formed. Finally, there is a new form of XY plot available that provides insight into mass versus time over the duration of the injection process. This chart makes it easier to understand how the injection process is performing throughout the cycle and specifically differentiates the flow and pack cycles so you can understand the mass contribution from both. As we have seen, SOLIDWORKS Plastics delivers much more flexibility and control with tools that provide more insight into the overall performance of our designs as they relate to the plastic injection process. Once again, my name is Chris Houlihan, and I would like to thank you for watching this video on what's new in 2017 SOLIDWORKS Plastics. If you have any questions or would like to purchase SOLIDWORKS, please reach out to us on social media or the Converge website. We would love to help you. Have a great day.